this is a DevOps conference, and that intrigued me a lot because for all the time I've been working in IT, the combination between actually making things work and writing them has been sort of very close to my heart. I started out as a sysadmin and started writing code because tools were missing, and well, then I just wrote them. So RRDtool, which is in the title here, is one such tool. The way this presentation is structured is that there will be a large part about RRDtool first, explaining also what it is for those who haven't met this little program. And then I'll also mention some other projects I've written since, which are all hosted on GitHub. There is always a link at the bottom of the slide where you can see where you can get these things. So it's all open source, what I'm presenting. You're free to use it. There are no license fees or anything associated with these tools. RRDtool is one of those infrastructure things of the internet in a way. Many people don't use it directly, but rather they use something like Cacti, SmokePing, Ganglia, Nagios, OpenNMS, some monitoring tool which produces graphical representations of whatever thing you're monitoring, and oftentimes these graphics are produced by RRDtool, and the data associated with the graphics is also stored with RRDtool, but the end users, they just see, oh, I'm using Cacti or I'm using SmokePing. So today it's about this underlying tool. And the interesting thing about it is that it's pretty simple to use. So when you have something small you want to observe and keep track of without setting up a separate server and monitoring infrastructure or anything, then you could quite well deploy RRDtool yourself and just do your little monitoring on the side. To show you how this works, I've put together a few slides explaining how to write a little traffic monitor. So if you have your Linux box and you want to see how much traffic it is transporting over the network interface. In Linux, there are those pseudo file systems. And when you look at the files in there, they're like files, but if you cat them, for example, then they'll show a different, this one here, RX bytes, will show a different number every time you cat it, because it tracks the number of bytes transferred over the respective network interface. So these, the stars here, they're just for abbreviation. Obviously, you will pick the interface you want to monitor. So with this information, I see all the traffic which is going through my network interface, or at least the one which is received. But just looking at the numbers doesn't give me a good picture of how much traffic there is. Does it fluctuate? Is there some progression in the traffic? Does it increase? Does it decrease? No idea. I just have the two numbers. So let's write a little monitor. And what I could do is I save the two numbers and I sleep 1 second in between, and then I build the difference, and suddenly I know at what speed my network interface is currently operating. So while I tested this, I was running at 3,940 bytes per second. So doing this on the command line is sort of nice, but you wouldn't want to do this all day long. So you have to do a little bit more coding. And that's where RRDtool comes in. RRDtool can take data you collect and store it in the database. Now, a database, most people, when they hear database, they maybe think of MySQL or PostgreSQL. But But those databases, they're optimized for storing data like addresses or information about processes, but it's all very structured, and there is text, there are numbers, and you want to retrieve exactly the data you store in the database when you do a query. With time series data, that's the kind of data I could collect from a network interface. It's a little bit different because the numbers of bytes which are transferred through this network interface, yeah, if I ask the network interface now, it'll tell me, okay, I've transferred 60 million blah, blah, blah bytes since whenever. And if I ask it again in 2 seconds, it'll tell me another number. But what is really interesting is the rate and not whether it's exactly this number and that number at the 2 times. So what I want to store is the rate of transfer. And also, if the rate fluctuates, it doesn't really matter if I ask for it at the hour, at 5 minutes past the hour, at 10 minutes, or at 1 minute past the hour, at 6 minutes past the hour, at 7 minutes past the hour. The exact sampling time is only important as far as the distance to the next sampling time is relevant. And so the kind of data is a little bit different than what you're normally accustomed to when you deal with data and SQL or NoSQL databases. So time series data is special. And there are products from commercial vendors, also other open source products which deal with time series data. The way RRDtool deals with time series data is that when you set up the database, you already specify quite a lot about the nature of this data you want to store. So here I'm setting up a database. It's called RxRD, and I'm telling RRDtool that it should store data every 60 seconds. And I'm also telling it that that data which I'm going to store is counter data. So the number on the interface, that's a counter. It's just increasing, and then at some very high number, it will wrap down to 0 and start increasing again. So I'm telling RRDtool, hey, it's a counter. And I'm also telling it that I'm going to update this at least every 80 seconds. And I'm going to tell it the rate I'm expecting is between 0 and 10 to the 9th, so 1 gigabit. So with this, I'm telling RRDtool already quite exactly what kind of data it's going to expect. And then I'm also telling it that it should store the data. And it should store averages. And it should do that for every minute, so 1 here. And it should do that for 24 times 60 minutes, meaning 1 day. So it'll store data for 1 day, for every minute, and then the data will be lost. And that's the sort of the big idea of RRDtool. It's able to lose data. The idea is that the older the data gets, the less interesting it is. And in this very simple example, it's going to store the data every minute, and then after a day, the data goes away. That's why it's called RRDtool, Round Robin Database Tool. It's creating a circular buffer, and it's writing into this buffer round, and when it comes to the start of the buffer again, it just starts overwriting. And with that, when you set up the database, it'll occupy a certain amount of space on your disk, and it will always occupy exactly this amount of space. So you'll never run out of disk space. You can always use this tool, monitor, and it will store the data in this pre-allocated space. So to put this into a little program, shell, I can run RRDtool update to load data into the database and feed it directly the numbers which I get from this counter in the sys file system. The letter N at the beginning of the third line is to signify the time, and N is now. This means RRDtool will look at the clock in the computer and timestamp this data with the current time. And then internally, it calculates the difference between the last sample and stores the rate. It doesn't actually store the numbers it gets from the interface, but stores the rate, and it stores that rate every minute. While this thing here runs maybe at 15 seconds past the minute, doesn't matter, RRDtool will store one value exactly every minute. And it does that by interpolating the data between the sampling points. And that's something which confuses a lot of people when they start working with RRDtool. They put in a number, and then they use RRDtool dump to look at the content, and they don't find their number again. And that's because RRDtool uses sampling to actually build those values which go into the database. The advantage of this approach is that you're totally free in setting up this program. You don't have to take care of actually sampling exactly at the minute. RRDtool takes care of that internally. Okay, so now you have your database, and it's being filled with that data from the interface, and now you want to go to your boss and tell him that you need, I don't know, a faster Ethernet card because it's always overloaded, blah, blah, something. Now the boss doesn't like big lists of numbers, he wants to see graphics. And that's why RRDtool is also able to produce graphical output. It has this function called RRDtool graph, where you can produce PNG, SVG, PDF graphics. It has some, well, simple options and not so simple. I'm just going to explain the simple ones here. You tell it when your chart should start. So with start -1h, I tell it that it should start 1 hour ago. And I'm telling it that it should start the graph at 0. So even if the numbers are always at 1 gigabyte, it will start at 0 so that you can see the distance. Often in newspapers, you find these graphs which are cut at the bottom and don't actually go down to 0. RRDtool would do that too, unless you tell it to start at 0. And then I'm telling it to retrieve the data from my RxRD file and draw a line in a color which I specify with this hex code. And, well, yeah, that looks like this. And suddenly, these numbers on the interface, which looked very hard to understand or difficult to judge, become much more approachable by having a graphical representation of them. So unfortunately, I don't see any of you because the lights are so bright, but who's actually using RRDtool? Way, no one is. So glad I explained what it is. Now, if you were using, just imagine, you would start with, I don't know, one little database, and everything would be so cool and so fast, and because RRDtool was designed from the beginning to be fast. And with this circular buffer, my idea was that I would always write just this one update into the buffer. So there would be very little writing going on. Just, I mean, one double number is 8 byte, right? So this is very little writing. So I thought, I didn't really know a lot, unfortunately, then. In reality, computers don't work like that. So when I write 8 byte to a disk, that doesn't work. Well, it works, but it works by the computer first reading, I don't know, one block. Today it's maybe 4K byte off the disk, then modifying that block by inserting the 8 byte, and then writing the 4K byte back. Which is still not all that much traffic, but it's much more traffic than 8 byte. And so the secret to high performance in RRDtool is to deal with these 4K blocks which are being moved around, or 512 if you have an old disk. Yeah, and so that whole reading the block from disk, modifying it and writing it back business is very expensive, especially the reading. And what computers do, if they have enough memory, is that they start keeping those blocks in memory. That's disk cache. And so when I modify data which is already in memory, I save the reading part. And only writing the block back will happen. And even cooler, the writing back of the block can happen at a later time. So it doesn't have to happen immediately, whereas the reading really has to happen, otherwise it can't be modified. So adding memory helps a lot. If you experiment with RRDtool on a physical real system with actual memory, you'll notice that performance will sort of go up the more you just add more and more writing or more RD databases, and everything looks so cool and so fast. And then at some point it just goes and your performance sort of crashes. And that's the point where not all the blocks which are currently being written to are in the cache anymore. And it's really quite amazing how the performance just totally kills itself as soon as the system runs out of memory. So the secret here is just add more memory. Faster disks, SSD, anything that's nice, but really the big thing is to have enough memory in your system so that all the active blocks of all those databases are being kept in memory, and as new data is added, they don't have to be read back from disk, only written to disk. Yes, so put as much memory into your system as it needs so that all the active blocks of your databases can be kept in memory, and then things will be fast. Okay, so for this tool you're not using, there are new things it learned over the last few years. For example, one thing people do is they create a database and they think, oh yeah, I'm going to keep my data for half a year, and then they use it and it's already 5 months, and suddenly they start noticing that the old data gets lost, and the boss says, what strange database have you chosen? Why are you losing data? You must keep the data for 5 years or at least. And yeah, RRDtool doesn't have a alter database function like in SQL. But what you can do in recent versions is that you can create a new database and you can use an existing database as the input. And the new database can have a different structure, it can have different sampling intervals, it can have different number of inputs, it can have different storage configuration, and if you specify a source, then all the old data from that source will be integrated into the new RD database. So in that way, you can drastically modify your database without losing any data. Obviously, if you have only stored 6 months, then the new database will also contain 6 months to start with, but if you set up a longer retention period, then it can keep data for longer. An important element of RRDtool is that you can specify multiple storage areas in a single RRDtool database. So in my example, I only had I had a storage area of 1 day and 1 minute interval. You could have in the same RRDtool database another storage area with half an hour interval and a month of retention time. And then when you put data in, it will fill both of those at the same time. And the one with the less resolution will keep the data for longer, whereas the one with the high resolution will only keep it for a day. And in that way, you can keep the data at whatever resolution you want for whatever duration you want. And the basic idea being that high resolution gets less interesting the older the data gets. So it's very interesting at first, but after half a year, you're not really interested anymore at the 1 second resolution you had for the first day. Oh yeah, and then it gets very esoteric, and yeah. So when you're drawing a graph, maybe that's also a very important feature of RRDtool. When you draw those charts, you can actually use reverse Polish notation math to calculate what should be drawn. So you can have little programs. Anyone used an HP calculator at some point? So it's those calculators, that idea is built into the RRDtool graph module. So you can use this reverse Polish notation math language to apply mathematical operations on your sampled data and then produce that as the output. And this here is about calculating a running total. So if you want to see how many bytes have been transferred over the course of a month, and you want a curve which goes up, 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 and then at the beginning of the month it goes down again, and then it goes up, 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 up. And with this extension here, you can sort of have normal input data, and while drawing the chart, calculate this staircase or this sawtooth graph. And some people like RRDtool, especially because of the graphing, because of this math you can apply to the graph before it gets drawn, and they don't want to use RRDtool for data storage. And there is an extension in the latest version which lets you register a callback. So whenever RRDtool graph needs to fetch data from disk, instead of actually doing it, it calls this callback where you can program whatever method of data retrieval you want. So you could have your data stored in a MySQL database and do some SQL queries to retrieve the data. Who is using Grafana? Yay! So the story. There is another thing called graphite. Anyone heard of that? And if you go to the website of Graphite and you search for RRDtool, there are some explanations as to that. Well, at first they have been using RRDtool, but RRDtool was not fast enough. And then later they changed it to actually it's faster than what we have now, but they didn't understand it. But in the meantime, they had written their own system, and they're not going to move back now just because it's very twisted, whatever. Anyway, so Grafana sort of it was built as a front end to Graphite at first, and now it's being used independently. And there is a, oops, what happened? Yeah, there is a Grafana RRD server project which is written in Go that can read your RRD database as a data source for Grafana. So you can integrate this into your Grafana dashboards. And since RRDtool is very space efficient, very fast, that can be an interesting option, especially if you don't have a really huge infrastructure to run one of the newer, very space-hungry options for time series databases. Yeah, the whole RD graph thing that intrigued a lot of people a long time ago. The first version of RRDtool was published in 1999. And then having graphs, static ones, people said, "Oh, that's so cool." Nowadays, graphs have to be animated, and people want to be able to go into the graph and look at details. And so I started this project called RDGraphJS, where I first thought of implementing a SVG-based front end in JavaScript to present those RD graphs in the browser. I soon found that due to all those math operations you can do on the data before it's being drawn, as well as many options for organizing the graph, that's quite a lot of work. And I did one version, but the features are much fewer than for the version which renders on the server. So I tried something else, and I want to show you this. So that's what a RD graph looks like. That's ping round trip times. And it's just a PNG, but I wrote a layer of JavaScript on top, which follows the mouse movement. So when I move the mouse and click the graph, then I can move the graph. And what's happening here is that as I'm moving the graph, it's just requesting new charts from the backend. So that's just a series of PNGs. And it turns out that even though this thing is running in Switzerland, it has latency and everything, it, well, works sufficiently well so that people can easily navigate in those charts. And the cool thing about this integration is that all you have to do in order to use it is add a little JavaScript to your web page, which will then start requesting the graphs sort of in the back. The only thing you need on the server side is that the server can produce the graphs on demand. So based on a URL it gets, the server has to be able to create graphs from different time points. Okay, so much for RRDtool. And for the remainder of my talk, I'm going to mention a bunch of other tools which I've written since, because most of the projects I do are obviously customer projects where the customer pays something, but often the customer is not really interested in the software itself, they're only interested in the solution. So they're happy with me publishing those things on the internet. And Sourcey Build Pack is one of those. So I was in a project where we wrote a large Perl application which had to run on Cloud Foundry. And I had no idea about this at first, but I started learning how Cloud Foundry worked and found that Perl is not one of the sort of officially supported languages on Cloud Foundry. And yeah, that's when I started writing that Sourcey Build Pack. So the idea there is that instead of using one of the existing build packs which are language specific, so PHP build pack or a Ruby build pack, I wrote one which is generic and lets you exactly specify which tools you need, which then get compiled and cached on Cloud Foundry and allow you to produce exactly your environment, not sort of an environment which happens to exist because there is a build pack which somehow works with your code. So while it has been originally conceived to make Perl run on Cloud Foundry, you can use it for any system where you need to compile special libraries or newer versions then are included on the base installation of Cloud Foundry, for example. Oh yeah, who knows about SPNigo? No. NTLM. So if you have Windows, do you use Windows in Russia? No, I thought so. So when you're using Internet Explorer or any browser on Windows, when that browser talks to a Windows server, it can optionally automatically, transparently log into the Windows server. You're nodding? No? Yes? Have you seen that? It's sort of creepy and magic and cool. And what is behind it is NTLM. And it's a system where the browser logs into the Windows server without actually telling the Windows server the password. It's sort of, people discuss whether that's secure or not, but it exists. And so it's a very tempting option to allow a browser to authenticate without the user having to input a password. Now, if you're about to write a program which wants to make use of this, then at first people say, ooh, then you have to run your program on IIS, because IIS integrates support for this, and it's very easy to do. But since I don't really am so fond of writing programs which run on Windows Server, because I much rather like to do this on Linux or some other Unix, I wrote this little module. And what it does is it sits on a web application, and when a Windows-based browser arrives, it tells it, hey, you have to do NTLM authentication. And the browser says, okay. And it has to be configured so that it is okay with doing NTLM authentication with me. But if it has been configured like that, then it will start the process. Now, my little program on Unix has no clue about the password of this guy, right? Because I'm not an Active Directory server or anything. But my program knows the Active Directory server. So browser comes in, starts its NTLM, and then my program goes to the Active Directory server and says, hi, I want to do NTLM with you. And the Active Directory server says, okay, here's your token. And my program gives the token back to the browser. And the browser takes the token, starts, and that's all legal. I mean, that's the way it's designed. So the browser starts doing its thing with the token and sends it back to me. And I can then use this to authenticate against the Active Directory server. And then I have a LDAP connection to the Active Directory server. And I ask that user, which has been coming in from the browser, and I can then do queries on the Active Directory server and figure out stuff about the user and decide whether that user is an okay guy to use my application. So it's sort of a man-in-the-middle thing, very convenient, and the users love it. And the DevOps also love it because that Linux server, which is running the application using that module, doesn't have to be modified with Kerberos and tokens and stuff. It's all running in the application. The application just needs the address of the Active Directory server. And that's written in Perl. There is also something similar written in Python, which also exists, but mine is cooler. Log fetcher. So we have this client who deployed all these nice antivirus boxes on their email system, and they also want to do logging. And for some reason, those antivirus boxes store the logs locally in files. And so I wrote log fetcher, which is a tool that can go into a Unix system, BSD, Linux, and figure out which log files are not being written to anymore and copy them out. So the idea is that you set the box up so that it rotates the log files, writing to one and then keeping copies of them. And the tool will fetch the copies as soon as it detects them and store them on another system where then the logs can be processed. And to make this work for many, many servers, that thing is written in a non-blocking style where it can handle many, as big as your memory is, basically, connections at the same time and fetch data from all those servers and store it in a local disk. Reverse proxies. Who's using Nginx? Yay, finally. Okay, I'm also using Nginx, but Nginx is sort of, well, yeah, it's sort of not very flexible in a way, because you have to have these plugins and everything. I like to write code. So I wanted to have a reverse proxy in code, which then I could use to do fancy things. And that's why I wrote this reverse proxy module for Motralicious, which is yet another Perl library. The cool thing about this reverse proxy is that it's non-blocking. So you can write applications which handle hundreds or thousands of web connections going through this single process in parallel, yeah, just like that. And it's very scalable due to this non-blocking structure of the code. So your machine doesn't need a huge amount of memory for many competing processes. It's just one process which deals with all these connections. Actually, it's a little horde of processes. You can configure like you do this with Nginx or with Apache. So it has all the structure of a big proxy server, except that it's all written in code and you can modify it and do to the requests whatever you want. And there's quite a lot you can do to web requests. Yeah, and while we're talking about proxy servers, there's the SMTP proxy. Who's using Nginx as a proxy for SMTP? Okay, so Nginx is not only a web proxy, it's also an SMTP proxy. And proxying SMTP with authentication, sort of cool, because you can tell Nginx to do a web request to do the authentication. The problem is when your SMTP email comes in and does the authentication, you have no idea about the email because the authentication happens first. And if you want to make sure that the headers of the email comply with some rules, then Nginx doesn't help you. This module sort of reverses this process. It accepts any authentication first, then lets the sender send all the headers, and then after the headers are here, it does a web request to figure out whether the authentication plus the headers are okay. And if not, kills the connection. And yeah, 1 minute, finally, JSON Hound. Who's using Cisco gear? No? Okay, some people do. With Cisco routers and switches, you can now get the configuration out as JSON files. And if you do that, then those JSON files contain all the information about the configuration of the switch and of the router. If you want to figure out whether the configuration is correct or not, let's say you're in the security department of your company, then you can analyze the JSON. And JSON Hound is a tool to do exactly that. So it lets you write complex rules to analyze JSON structures and figure out whether they comply with your expectations. And it's much more powerful than JSON schema, for example, which does something similar. That thing actually can be programmed. It can figure out relationships between different parts of the JSON. And our customer is using this to do security auditing on routers and switches. And it's written in Perl 6. Okay, so I'm running out of time. Yeah, that story, it's a really cool story. So has any one of you ever had to debug a performance problem involving users, where the users were unhappy about the performance? Okay, so because that's very hard, right? Because often they complain and then you go there and you can't see the problem. Everything's fine. And then you go back and then suddenly the problem is back and the users are unhappy. It's a very poisonous atmosphere. And that's when I came up with this little tool. It's written in C#, it's running on Windows, and you can launch it on Windows box, and it adds a little icon at the bottom of the screen. And whenever the user experiences a problem, he clicks on the icon, and at that moment, the program gathers a bunch of information about the state of the machine and lets the user input the comment and click one of these buttons. They're configurable, so according to whatever problem you're currently hunting down, and then sends an email to a configurable address. This allows you to give the users sort of a handle in helping with figuring out the problem, which is almost half the rent already. And then you also get very helpful reports of when it's actually happening, where it's happening, and what the state of the machine is in when this problem is occurring. So we had some great effects in solving the problem, but also in making the users see that we're actually tackling the problem because they're getting this application and have part in solving the performance problem. Yeah, skipping that. So all those tools and many more are on my GitHub repos. If you care to have a look, they're all there. Most of them come with setup instructions and installation helpers. So feel free to use them and ask me questions if you have any, or ask them now. So,
thank you very much, Tobi, for sharing your tools with us. And this is a certificate of honor.
Okay.
Yeah.
Wow.
Thank you very much for coming here.
Thank
and
you.
This is a small gift from an organization committee. It is Bluetooth speaker.
Thank you.
And maybe we have no so much time. You can ask your questions maybe to Tobi in person. И хочется сейчас задать вопрос, окей?
Thank you, Tobi. It was quite interesting. Besides, maybe the technologies from past, like Perl. Nobody like to read Perl. Almost
depends on the writer.
Yeah, it's write-only language, and nice write-only language. Okay, and the question is, how big team of engineers you are working with?
At my company, we're 5 people.
5 people, and how good interoperability between team within team, because it looks like you write many small solutions for the problems you have right now.
Yeah.
And most of them work for you in just this time, and maybe you don't need it in the future. So the question is how hard to work with team with such solutions.
So the solutions are mostly for a specific customer problem, and we're not using them for our problems, or sometimes we do. Interestingly enough, what happens is that often I write something for one customer, and then the next customer seems to have the same problem.
Nice.
So it works out quite well.
Thank you.
Еще вопросы? Слав, передай его туда. Можете говорить по-русски, если вам так удобно.
Yep, thanks for
Это будет последний вопрос.
All right, so I have a question about one really interesting scenario from my side. So if we want to visualize data from RRDtool and we want to create like a live dashboard, so what is the best way to do this?
Well, I think Grafana is a cool way to achieve this. And then if you already have a deployment of RRDtool with existing tools which use RRDtool, then this RRD.js is a very simple way of sort of making your current static graphs into suddenly live graphs, because the change in HTML is really small. And then you just replace the bit of HTML code and you're done.
Okay, thanks.
Okay, we have run out of time. It's maybe my fault. And Tobi, you can choose your favorite question.
That's so unfair.
Yeah, absolutely.
Do you agree? His was so cool.
Come here and introduce yourself, please. This is a gift certificate for a business book.
Wow.
Read that now.
Congratulations.
Andrei.
Congratulations, Andrei. You have earned a business book.
Yeah. Yeah. Thank you all very much.